So, lesson 4A, it's solving problems with trig. Couple of vocabulary words. You're already a little familiar with this, but angle of elevation, the angle through which the eye moves up from the horizontal to look at something. So, that's like if you're looking at the top of the building. The angle of elevation is the difference between your horizontal and your line of sight going up there. Okay, so that's your angle of elevation. Angle of depression is if you're standing on top of a building, here's the horizontal, and you're looking down. Okay, so that's angle of depression. We'll definitely work with that one because that's an important one. So, let's talk about the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. Okay, you can guess what I'm going to do. I'm going to draw a picture. Now, here is my lighthouse. Your lighthouse can just be a vertical line if you want it. Okay. We have this lighthouse, and we have the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse. So the idea here is somewhere out here, there is a buoy. Something floating on the water marking that location, right? So there's my buoy. And we're talking about the angle of depression from the top of the Barnegat Bay Lighthouse. So, what shape did I just draw? I just drew a right triangle, folks. Okay, now, stick with me. The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water. What's 130 feet? Height of the lighthouse. So this side right here has a height of 130 feet. Now, okay, here's what you have to watch. The angle of depression is 6 degrees. The angle of depression is the difference between the horizontal and where your eyes are looking down. Folks, here's the horizontal. The angle looking down is this diagonal line I already drew. 6 degrees, I need you to realize is right there. Now, this is where a mistake happens because we often tend to think 6 degrees is right here at the top inside the triangle, but it's not. Okay, are you guys with me here? So that 6 degrees is outside my triangle for the moment. Now, okay, and find the distance x from the base of the lighthouse to the buoy. So what am I trying to find? X right there. Okay, what do you know about these angles in the triangle? How could I find one? Okay, could we do 90 minus 6? 90 minus 6 is 84. What's that make this angle at the buoy? 6. Okay, fun geometry theorem. If two parallel lines are cut by a transversal, alternate interior angles are congruent.
Yeah.
Does that sound the least bit familiar? Parallel line, transversal. I don't know if alternate interior words are still the right lingo. That's just what I remember from my geometry career. So, inside the parallel lines, opposite sides of the transversal. So did you even have to find the 84? Not really. You should have just used 6. Or you could have just used 6. Okay. Give me a way to find x.
Personally, I would go 10 of 84 equals 1. X over 130.
Is that an option? Okay.
Because I don't want to divide it by tangent.
He says tangent of 84. What's tangent? TOA. Opposite over adjacent. So x over 130. Now, I'll be honest. In my notes, I actually used the 6-degree angle. So I said the tangent of 6 degrees. And here's my thing. I didn't find the 84. I didn't do that subtraction. I just used my geometry theorem and said, that's 6, then that's 6. So if we do tangent of 6, then it's 130 over x. You guys remember how to solve? Either way, it's going to give you the same answer, right? You're either multiplying the 130 over, so x is 130 times tangent of 84 degrees, or you multiply the x over, so x times tangent of 6 degrees is 130, and x is 130 divided by tangent of 6 degrees. Either way, what'd you get as an answer?
1,236.87.
Okay. 1,236 and 87/100 feet. If your calculator didn't give you that answer, you should check your settings. What mode do we need to be in? Degrees, not radians. Okay, we need to be in degrees, not radians. And it's going to tell you right here, see right there, it says degrees, so you're in degrees now. So now if you redo that, you'll get the correct answer. Okay? Okay, are we good on this one?
Yeah, thankfully.
Yep, that's something I would say. You're probably just not caught up on that piece yet. Okay, example 2. From the top of the 100-foot tall Altgett Hall, a man observes a car moving toward a building. If the angle of the depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Okay. Now, this was a little more complicated, yes? Here is my fancy Altgett Hall. This is from the top of a 100-foot tall hall, right? A man, so we have a man standing on top. He observes a car moving towards the building. So somewhere, and I'm going to make it quite a bit over here, somewhere we have a car over here. Okay? And this car is moving towards the building. Okay? Now, with that in mind, it says the angle of the depression of the car changes from 22 to 46. So we're looking at, gosh, that was a horrible line there. Yeesh. Okay. We're looking at, he first spots the car way out here. And then what happens? The car drives a little bit, and then he spies the car again. So now, we've got a second spot that he sees the car. So you've got 2 triangles going on. Okay? Now, notice, we did create right triangles. You have right triangle within right triangle. And they gave us the words angle of depression again. So angle of depression, looking out from the horizontal. Now the angle of depressions are going to be outside. The first time, what was it? The angle of depression of the car changes from 22 to 46. So when the guy sees the car out here, the angle of depression is 22 degrees. Yes? Now, play the game with me. If that angle is 22 degrees, what else is 22 degrees?
The bottom part. Yeah, that one.
Where the car started is 22 degrees, right? That's going to be your easiest route on this one. Now, the angle of depression changes to 46 degrees. So now what's happening? Now, angle of depression down to this next line is 46 degrees. Okay? If that's 46 degrees, where am I going with this? Where the car arrived secondly is 46 degrees. Are you there? Now, the question is, what are they asking?
So far as the car travel, so it'd be the base of that farther out triangle.
How far does the car travel? So we're being asked to find, I'm going to call it X. Now, is that the side of a right triangle?
No.
It's not.
I have actually back right there multiple times.
No, we're going to do trig functions multiple times.
Okay, multiple.
Okay, so here's what we're looking at, guys. We have two right triangles. We have the right triangle that has the 46 degrees, yes? We can find the bottom of this side. I'm going to call it D.
Then I can find the side of the big right triangle and we can subtract, and that's a lot unnecessary work.
Okay, now, we can also find my big triangle that has the 22. We can find the bottom of that side. And I'm going to call that, I think I have it Y in my notes.
Or just B plus X.
Okay. Now, with that in mind, I'm going to set up two equations. And as Logan said, we're going to subtract in the end. Okay? Are you with me? Let's start by finding D. D is right here. How can I find D? If we use the 46-degree angle, what do we know? It is the adjacent, and we know the opposite. Adjacent and opposite are tied together by tangent. So I'm going to say tangent of 46 degrees is opposite over adjacent, 100 over D. Okay? How are we going to find D then? Are we quick enough on this? You realize it's going to be 100 divided by tan of 46? And 100 divided by tan of 46?
96.57.
Okay. Make sure you leave several decimal places there, because my answer is going to have two decimal places. So 96.5688, so on and so forth. Now, let's find Y. Y is the big distance. It's the whole big triangle. We have 22 degrees here. We still know the 100, don't we? And we're trying to find Y. So now I can do same thing basically, right? Tangent of 22 degrees is 100 over Y. Multiply the Y over and divide, and Y is going to be whatever 100 divided by tangent of 22 degrees is. According to my notes, or did you guys get it?
247.5087.
Okay. I wrote 5086 just before it rounded, but. How do I find X? You're going to do Y minus D, yes? The 247 number minus the 96 number. X is Y minus D, which is what? 150.94 feet. Okay?
Oh, I think I remember how to Just
Now, okay,
maybe pull some.
real quick, I'm going to throw in example 3. It's a quick one. Okay, it's not a word problem, but we need to find theta. 25 and 62 are what sides of the angle in relation to theta? They are the opposite and the adjacent. What trig function uses opposite and adjacent? Tangent. So I'm going to say tangent of theta is 25 over 62. Now, I know the output. I need to find the input. What allows me to switch the input and the output? Inverse. So what we can do to find this is switch your input and output. Now you're doing tan inverse of 25 over 62, and that will give you theta. Okay, so tan inverse allows you to switch input and output. Now, I don't really want a radian answer here. You're going to want to be in degrees because degrees is the answer that's going to make a little more sense to us. And I think you're pretty much in degrees for this whole homework. 2 decimal places, 21.96 degrees. Okay? I know I went fast, but I will say you guys are familiar with the trig functions, right? We've been doing the trig functions. You're familiar with them. Okay? Set the problems up. Draw your pictures. Set the problems up you can. Come back for help tomorrow or Friday, whichever it is.
62.
Now.
Do you hate us?
What? Oh, you're on that. Okay. Homework, page 386, 1 through 13, 15, 16, and 19 through 24. If we were to happen to be on e-learning tomorrow, I would say finish this assignment and start working on the review worksheet for the test that I just gave you. Okay?